Hello. Today we're going to be going over the HeartBleed SSL exploit. Here's all the background information that you need. Introduction to HeartBleed and SSL HTLS. It says on the internet today, most web servers are configured to use SSL TLS. Secure socket layers is a predecessor to TLS, transport layer security. The most common versions are TLS 1.2 and TLS 1.3. Recently released, configuring a web server to use TLS means that all communication from that particular server to a client will be encrypted. Any malicious third party that has access to this traffic will not be able to understand, decrypt the traffic. And they also will not be able to modify the traffic. To learn more about how TLS connections are established, check 1.2 and 1.3 out. HeartBleed is a bug due to the implementations in the OpenSSL library from versions 1.0.1 to 1.0.1f, which is very widely used. It allows a user to access memory on the server, which they usually wouldn't have access to. This in turn allows a malicious user to access different kinds of information that they would usually have access to due to the encryption and integrity provided by TLS, including server private key, confidential data like usernames, passwords, and other personal information. Analyzing the bug. The implementation's error occurs in the HeartBleed message that OpenSSL uses to keep a connection alive whether there is no data is sent. A mechanism like this is important because if a connection dies, resets quite often. It would be expensive to set up the TLS aspect of the connection again. This affects the latency across the internet, and it would make using services slow for users. A HeartBleed message sent by one end of the connection contains a random data and the data lengths. This exact data is sent back when received by the other end of the connection. When the server retrieves this message from the client, here's what it does. The server constructs a pointer, memory allocation, to the heartbeat record. It then copies the length of the data sent by a user into a variable called payload. The length of this data is unchecked. The server then allocates memory in the form of 1 plus 2 plus payload plus padding. This can be a maximum of 1 plus 2 plus 65,535 plus 16. The server then creates another pointer, BP, to access this memory. The server then copies the payload number of bits from data sent by the user to the BP pointer. The server sends the data contained in the BP pointer to the user. With this, you can see that the user controls the amount and length of data they send over. If the user does not send over any data where the length is 0, it means that the server will copy arbitrary memory into the new pointer, which is how it can access secret information on the server. When retrieving data this way, the data can be different with different responses as the memory of the server will change. Remediation. To ensure that arbitrary data from the server isn't copied and sent to the user, the server needs to check the length of the heartbeat message. The server needs to check the length of the message of the heartbeat message sent by the user isn't 0. The server needs to check the length doesn't exceed the specified length of the variable that holds the data. There's references right here if you want to further read into it. So let's get into the actual task. It says in this task, you will need to obtain a flag using a well-known vulnerability. Make sure you pay attention to all the information and errors displayed. Pay particular attention to how web servers are configured. This server takes 3 to 4 minutes to deploy and configure. Be patient. Easiest way to go about this is good old MF Metasploit. So you search for HeartBleed because that's the exploit we're looking for. So there's several different scanners that you can use. We want the 3 or 4. We'll go with 4. Okay. set verbose so it actually puts output out. So now you got actual output to sift through. And it's pretty clear. Right here's the flag. Quick, simple. Thank you for watching. Till the next time.